Hi everyone and welcome back. So now we're going to be talking about limits by substitution. So you are going to want to have your calculator out, so let's have that handy. So maybe pause the video here, go grab your calc, and come right back. Alright, so for the first question, we're evaluating the limit of a rational function. Hopefully you remember our rational functions unit. That's when we had horizontal asymptotes, vertical asymptotes, those slant asymptotes. So this is a function like that. So actually, just from looking at this, I can immediately already tell that there is going to be a vertical asymptote. Before even graphing it, I already know that there's a vertical asymptote at x equals 2. But now, I am going to graph this. I put this in my calculator already. And we are looking at something like this. All right, got my vertical asymptote at x equaling 2. So there's what my graph looks like. Okay, and if any of you remember, you actually have a horizontal asymptote at y equals 1, because this is equal heavy. So you take the ratio of the leading coefficients. Fun fact. All right, so there's my graph. This is x equals 2. And we're going to evaluate the limit. So as x approaches 2, remember, you got to look at it from the left and from the right. So as x approaches 2 from the right, well, let's see what happens. As I approach 2 from the right, that's going towards infinity. And as I approach 2 from the left, we're going towards negative infinity. So because I'm approaching two different values of positive infinity and negative infinity, the limit does not exist. Okay, let's take a look at a few more examples here. Again, I'm going to be sketching these out as best as I can. You should be doing this with your calculator just to verify and check with me as well. All right, so let's take a look at our next one. So in my calculator, when I graph this, it looks like this. So just sketching it out. My axes, I actually end up with a parabola. And now hopefully, again, I'm getting a little ahead of ourselves here, but you should notice that this is actually able to be factored. So if I were to factor this by using my sum and difference of cubes, so you see how I have t cubed minus 8? Well, I can rewrite this as t cubed minus 2 cubed, and there is a formula. So following my formula, I would have t minus 2 times t squared plus 2t plus 4. So that's what my top part of the numerator would look like, all divided by t minus 2. So you should remember, again, from our rational functions unit, because these cancel, there would be a whole at t equaling 2. So because we're approaching 2, there is actually going to be a whole here. And now if I just check, now again, I'm going a little bit ahead of ourselves here. Right now, I really just want you to graph it, but this is where we're going towards here. But right now, all you got to do is just graph it. So if you look on your calculator, now if you try to go to the table, if you check in the table when t is equal to 2, what do you notice? You should notice when you check the table, when you click diamond F5, it says undefined when x is equal to 2. Remember, because there actually is a hole here, this is our new equation. We're going to plug 2 in for t. So I would have 2 squared plus 2 times 2 plus 4. I have 4 plus 4 plus 4, which is 12. So my answer here is actually 12 for this second one. And again, guys, you can always rewind, pause the video at any point just to get some clarity. Because the reason why we can't plug in directly to this equation right here is because look what happens if I plug 2 in. I have 2 minus 2, which is 0. Can't have something undefined. Same thing here. If I plugged in 2 here, it's also going to be undefined. So that's why I do want you guys graphing these first to take a look. And then also very similarly for question 3 here, if you plug in this negative 3 for x, again, it's going to be undefined. So let's graph this in our calculators and check when x equals negative 3 what you get. And you can always check with the table. All right, now when I graph this, we are looking at something like this. Kind of weird. But all right, no problem here. So now if we check when x is -3, so about here, when I go to my table, when I go over to -3, also says undefined. So that means there's also going to be some kind of hole here as well. Now I want you to just look at your table. We're not going to go into algebraically doing this yet. If you just check your table, let's just check some values above and below. Think about how we were doing this in the previous lesson. So I'm going to check when x is -4, -3, we know it's undefined, and then -2. That way I can kind of approximate where I roughly think this would be. So at -4, I'm looking at 0.26795. This is all coming from the calculator, guys. And then at -2, I'm at 0.23607. So roughly, just to make an estimated guess, at -3, where would that hole be? Well, I would say between 0.23 and 0.267. Maybe it's around 0.25, which is roughly, that would be 1/4. So maybe I'm going to make a guess and say that this is at 1/4. All right, so there's my final answer. Remember I talked about in my previous video, where if you're given a table, you can kind of estimate what that value would be in between. All right, so algebraically, why does it make sense that these limits are all undefined? Well, again, if you were to plug all of these in, we said this earlier, all of these would be undefined. You can't divide by 0. You cannot divide by 0. So if you just plug it in, it's not going to work out, right? If I plugged in 2 here, I'd have 5/0. If I plugged in 2 here, I would have 0/0. And then if we plugged in -3 here, I would have 0/0 again. So all situations that cannot occur. Alrighty, I know I spent a lot of time on this, but this is all really important stuff because this is all brand new. All right, so let's consider the following limit. So we're going to directly substitute in now. And the reason why we're allowed to substitute in directly here especially is there's no dividing by 0 possible here, right? There's no fraction. We can just plug right in. So the limit of x squared minus 3 as x approaches 3. Well, we're going to plug 3 in. So I have 3 squared minus 3 is 9 minus 3, which is 6. And again, really important to talk about here, this is a continuous function. So we know that this is a continuous function. If we were to graph this and check the limit from either end, let me make a little sketch here. So if we were to graph this, my graph would look like this. And we're checking the limit as we approach 3. So 1, 2, 3. That's about the point, maybe about here, where there's the 6. And we have to check the limit from the left-hand side and the right-hand side. And as you can see, it's from both ends would be approaching that value of 6. So that's at 6. Okay? Now, is there another way we could have done this? Well, we just established both methods. We have both graphically and we have algebraically by directly plugging in. So we have algebraically and graphically by plugging in here and then also by checking the graph to see what it looks like. All right, awesome. Let's keep going. So again, we're just going to plug in directly by doing limits by direct substitution, right? In this situation, there's no way this could be undefined. Similarly here in this situation. So let's plug in. So we have the limit as x approaches 2 of 2x plus 8. Well, I'm just going to plug in 2 times 2 plus 8. So this limit is going to approach 12. Now, if I check my third problem, and guys, you can do this all without me. You don't need my help for this. We're just plugging in. We're going to take the limit as x approaches 1. So I have -1 squared all over 2 plus 2 times 1 plus 4. When I simplify this, I end up getting 5.5. So the limit as x approaches 1 is 5.5. So maybe pause the video here, see if you can do questions 4 and 5. Again, you don't need my help for that. Okay, so for question 4, we just plugged in 2. and you'll end up getting 0. And then for question 5, you have the limit as x approaches -1 of the function, and the function is, if anything, it's just 5. So as x approaches -1, you already have your answer here. It's approaching 5. So that's it for that. All right, so let's look at questions 6 and 7. So this requires us to recall our trigonometry. So I'm going to draw my unit circle here on the side. I've got 1, 0, 0, 1, -1, 0, and 0, -1. So I want to take the limit as x approaches 0 for sine of x and cosine of x. So I'm going to rewrite this, and remember, this is just a little side note. Sine over cosine, remember that's just tangent. Okay. All right, so we got to be careful here because remember, if this becomes 0 in the denominator, it's undefined, and that can't happen. So let's see. We have the sine of 0. Well, sine is the y values. So sine of 0 is 0. So I have 0 all over. Cosine of 0, that's the x values, all over 1. So this is just 0. Similarly now over here, I have just kind of now the reciprocal here. Cosine is the x values, so I have cosine of 0 is equal to 1. Sine of 0, remember those are the y values, so I have 1 over 0, because I'm plugging in for sine. And now I'm looking at something that's undefined, and that can't happen, so the limit does not exist. The limit does not exist. Okay, now let's take a look at exercise question 8. So we have the limit as x approaches 3 of x minus 3 all over x squared minus 9. So we're just plugging in. We have 3 minus 3 all over 3 squared minus 9, and I get 0 over 0. Now, this is something very special. We call this indeterminate form. So by direct substitution, if you get something like this, that's 0 over 0, we call that indeterminate form. When that happens, that actually means you can factor this. So let's actually do that. We're going to see how you can actually factor this problem. So I'm going to rewrite. This is actually really important. You can't drop the limit until you've actually plugged in for x. So I'll say that again. Don't get rid of the limit until you've plugged in for x. So we're going to rewrite this as x minus 3 all over. I'm going to factor the bottom. I have x minus 3 and then x plus 9. I can simplify this because these are going to cancel. So I can rewrite this as the limit as x approaches 3 of 1 over x plus 3. Again, don't drop the limit. This is important. You can't just get rid of it. Now I'm going to plug in so the limit disappears. 1 over 3 plus 3, which is 1/6. So before, we found that it was 0 over 0. But really, after factoring, the limit is 1/6. Okay, so we're actually going to be practicing factoring limits here. Factoring the function of the limit. So let's take a look at exercises 9 through 12, and then we got a little bit more practice. We're just getting a little practice with this. So again, if you were to plug this in directly, you would see you have 2 cubed minus 8 all over 2 minus 2, which is 0 over 0. That can't happen, and because it's an indeterminate form, that means we know we can factor. So let's factor this. We'll have, so we need to rewrite the limit. You can't just drop the limit. We'll have the limit as x approaches 2. And x cubed minus 8, that is a difference. That's a perfect cube, difference of perfect cubes. So we can rewrite this as x cubed minus 2 cubed. You guys need to know your sum and difference of cubes. We did this in the beginning of the year. All right, so if you need to, make sure you have these written down. I'll write them down. If you have a minus b times a squared plus ab plus b squared. This would be if you had a cubed minus b cubed. And then if you had a cubed plus b cubed, you'd have a plus b times a squared minus ab plus b squared. All right, so those are your two formulas. Please make sure you have these written down if you forgot them. All right, so moving on. So using my formula here on the right, I'm going to rewrite this x cubed minus 8 is really x minus 2 times x squared plus 2x plus 4. So I'm going to write that up here. We'll have x minus 2 times x squared plus 2x plus 4. So now I'm just going to clean this up and let's evaluate this limit. All right, and this is all getting divided by that x minus 2. Notice that these will cancel. So we're going to rewrite. We have the limit as x approaches 2 of x squared plus 2x plus 4. And now I'm going to directly plug in the 2. So now the limit goes away because we're plugging directly in. So I have 2 squared plus 2 times 2 plus 4. Guys, I can't emphasize enough how this limit cannot just disappear. It can only disappear once you've plugged in for x, then it goes away. All right. When I type this all in to my calculator, or you could just do this in your head, really you have 4 plus 4 plus 4, which is 12. So that's after evaluating the limit. Noticing at first it was in indeterminate form, knowing now we can factor. So let's take a look at a few more examples. I'm going to do question 10 with you guys, and you guys should be able to do 11 and 12 on your own. So always plug in first, see if it works. If it doesn't work, if it's in indeterminate form, then you can factor. So I'm going to plug directly in for question 10. We're plugging in -1. So I'll have -1 plus 1 over -1 squared minus 1. And I get 0 over 0. So because I can't have that happen, I'm going to factor wherever I can. So I can actually factor the bottom here. So we're going to write, this is the limit, don't drop the limit, as x approaches -1. I have x plus 1 all over, this is dots, so I have x plus 1 times x minus 1. These are going to cancel. Still going to write, I have the limit of x approaches -1 of 1 over x minus 1. Now the limit disappears because I'm plugging in for -1. And you'll get -1/2. All right. Why don't you guys try questions 11 and 12, and let's see if we get the same answers. So try 11 and 12 on your own. I would pause the video here. All right, so there's my work for question 11. I first saw when I plugged in as x approaches 2, I plugged 2 in for x, and I got 0 over 0, which is indeterminate form. So then I went back and I said, oh wait, I can factor. I factored it out. I canceled the x minus 2's, and I plugged in when x equaled 2. We have 2 plus 4 is 6. All right, so again, pause the video here and try question 12 on your own. Alrighty, guys, there you go. There is our answer for question 12. Again, I saw I plugged directly in, so there's no need for a limit right here because I plugged directly in for x. And I saw I got 0 over 0, which again is indeterminate form. And then I said, wait a second, again, this can factor because that's dots. Don't drop the limit until you actually plug in for x. Alrighty, let's get a little bit more practice in. I'm going to introduce something new for us, and you guys will be all good to go. So let's take a look at questions 13 through 15. So please stay along and pay attention because this is something kind of new for everybody. Now, here, again, we're going to plug in for our x values right away, see if it works out. So I'll have the square root of -3 plus 7 minus 2 all over -3 plus 3. I'll end up getting the square root of 4 minus 2 all over 0, and I get 0 over 0, which is an indeterminate form. But now, well, before you told me that we could factor if this happens. I don't know how to factor this. So what we're actually going to do is we're going to multiply by the conjugate. Do you guys remember earlier in the year when we had questions like this? I'm going to write it actually as the reverse because this is more so what you were used to seeing. And I said rationalize the denominator. We would multiply the top and the bottom by the conjugate where we just change the middle sign. So I would change this from the square root of x plus 7 plus 2, and I would do that on top and bottom. Now, the only difference here is they're reversed. right? So what we're going to do is multiply the top and bottom by the conjugate of where you see the radical. So I'm actually going to multiply the top and bottom here by the square root of x plus 7 plus 2 all over the square root of x plus 7 plus 2. A little bit different here. I know you might be thinking, well, why are we making this denominator have a radical now, right? You're used to rationalizing. Well, this is a different process. We're not rationalizing the denominator. We're merely going to try to cancel terms, because when I multiply by a conjugate, remember, terms cancel out. So let's start to evaluate this. And remember, do not drop the limit. So we got to double distribute. Put those double parentheses around, double distribute. Square root of x plus 7 times square root of x plus 7 is just x plus 7, right? I have square root of x plus 7 plus 2. So I have 2 times x plus square root of the whole thing there. Then I have minus it. Remember, I said things are going to cancel out. And lastly, minus 4. I'm going to leave the denominator as is. I am not going to start multiplying that because that's going to get a little gross. All right. Well, we see things are going to cancel, so don't drop your limit. I have, this is going to cancel with this, and I have x plus 7 minus 4, which will be plus 3, all over x plus 3 times the square root of x plus 7 plus 2. And would you look at that? These are also going to cancel. So now I have the limit as x approaches negative 3 will be 1 over the square root of x plus 7 plus 2. And now we're going to evaluate the function by plugging in, so the limit goes away. I'll have 1 over the square root of negative 3 plus 7 plus 2, which is 1 over the square root of 4 plus 2, which is 1/4. And that's my final answer. So something that we thought couldn't be solved because it was 0 over 0, we actually were able to find its limit being 1/4. All right, so let's take a look at example 14. So again, you should be plugging in directly. I'm going to erase what we have here just to make some space, but let's plug in directly. All right, so plugging in directly, let's see. Remember, no limit needed because I'm doing this direct. I'll have 0 plus 3, which is just 3, minus red 3, all over 0, and I have 0 over 0, which again, we know is indeterminate form. Now, remember what we said earlier. If it's an indeterminate form, that means we can manipulate our expression so that way we do get a limit. We do get a value from our limit. Now, can't factor anything here. That's not going to work. So let's do what I just showed us before. We're going to multiply top and bottom by the conjugate. Okay, we're going to do that where we see the radicals. So I'm going to do the square root of x plus 3 plus radical 3. And we're multiplying it on top and bottom because really this is just a form of 1. So we're not changing the expression. There's nothing wrong with multiplying top and bottom by the same thing. That's just that form of 1. All right, and again, so we're multiplying the conjugate where we see that square root or the radical. So we're doing that on top and bottom. Again, like I said earlier, you guys were used to seeing things like this in class where the whole purpose was to rationalize the denominator. So we did multiply top and bottom, and the radical was always in the bottom. But now that's not always going to be the case, especially when we're dealing with limits. So this is more so what you saw when we were in school early in the year. So now when we multiply limits with the conjugate, we're going to be multiplying it wherever we see the radical. So I'm going to do my double distribution, put my parentheses around there. All right. And I'll have the limit as x approaches 0. I'll have x plus 3 plus square root of 3 square root of x plus 3 minus square root of 3 square root of x plus 3. And then I have rad 3 times rad 3, and there's a minus out front, so this will be minus 3. All over, I'm going to leave exactly as it is. I'm not going to simplify the denominator because you're going to see some things are going to cancel. Keeping that limit, don't drop it. I'll have, in the middle, you should have noticed, these two things are going to cancel. And something else cancels. I have a positive 3 and a negative 3, so I'm actually just left with x in the numerator. All over x times square root of x plus 3 plus rad 3. You should notice what happens actually really nicely is that these x's cancel. So I have the limit as x approaches 0 of 1 over square root of x plus 3 plus radical 3. And now we're going to plug in. So I'll have 1 over rad 3 plus rad 3, which really, this is just 1 over 2 rad 3. And if I rationalize this by multiplying top and bottom by radical 3, you guys are like, oh my gosh, when does it end? I know, there's a lot of steps here. You'll end up with rad 3 all over 2 times 3, which is 6. So in the end, we get rad 3 over 6 is our final answer. So again, we went from being in indeterminate form for this problem to now my limit as x approaches 0 is really rad 3 over 6. Why don't you guys give question 15 a try? This is our last problem of the day, and we're just doing limits by direct substitution. So check it, make sure, see if it gets into indeterminate form, and if it does, multiply top and bottom by that conjugate. So I would pause the video here and let's see if we get the same solution. All right, and there you guys have it for question 15. You should have gotten your answer to be 1/4. So this actually was the same answer as the answer to question 13. All right, guys, I hope you found this video helpful. This lesson was purely all about being able to evaluate limits by using substitution. We talked about solving limits by using the conjugate, and we also solved limits by using factoring. All right, so two big steps for us, factoring and multiplying by conjugates. All right, I hope you guys found this video helpful. Get started on your homework. We'll talk soon.